Hello, I'm Randall Carlson. I would like to welcome you to a very special episode of After School. I'm a designer and builder by profession, but have for many years been an avid investigator into the marvels and mysteries of this amazing world we inhabit. I would like to invite you to join us here on a journey into the realm of sacred number and symbol and the forms, patterns, and cycles of both space and time in which these numbers are embedded. Today, thanks to the talented team at After School, we'll take a peek behind the veil into the ancient symbolism of sacred number that still exists as part of our everyday lives. The animation format employed here is a powerful medium for conveying the essence of this knowledge. So, without further ado, let us begin.
What's up, Big Baron? How you doing, broski?
So what is the universal language? It's symbolism. It's number and symbolism and form. And number, symbolism, and form are universal regardless of the spoken tongue, which one happens to have been brought up in. And hopefully in the next hour
amazing,
and a half,
bro,
I'm gonna be showing
amazing.
you examples of this so that you can see for yourself what actually the
Amazing,
universal
buddy.
language of geometry and symbolism.
Where are you going, Atlantic City or something?
So we're going to jump right into
Oh,
it
yeah,
here
bro.
and talk about
Myrtle
sacred
Beach?
numbers embedded in everyday phenomena. These are the things that
You're
we
gonna love it,
all
man.
pretty much
Avalon, nice, buddy.
think about and use on a daily basis
Nice.
without ever really pondering the fact that there's
Sweet.
actually deep symbolism hidden within them. We measure our life in terms of days, 24 hours, referred to as a tropical or
That's pretty
solar
fun,
day.
man.
And it turns out that 24 of these hours are 1,440 minutes. This is one of the key numbers within the ancient canon of numerical cosmology that the ancients used to basically design and create their world. The 1,440 minutes equates to 86,400 seconds. So if you just listen to these numbers, look at them, and let them kind of soak into your brain, once you've gotten into this as actually a system, a methodology of transmitting information, these numbers are actually carriers of information because each number stands for meanings beyond just the apparent ones. So we see 1,440 minutes is equal to 86,400 seconds, and a 12-hour span of time, which is usually represented on the clock, 720 minutes, which equals 43,200 seconds. So just look at those numbers. You'll think that obviously 43,200 is half of 86,400. The 1,440, we're going to counter that number again here momentarily. So these are just examples
Nice,
of some
buddy.
of the time,
That sounds amazing,
how
bro.
we think about time in our particular
Sounds like it's gonna be amazing.
space measure. We talk about a foot. We talk about
I'm gonna Google it right now.
12 inches. We talked about a square foot. And you'll notice that the square foot has the same repetition of digits, 144.
Oh man, that looks
as
real
the
nice,
24
man.
hours does. All we do is we
It looks
tack a
really
zero
nice.
on that. We have the number of minutes in a day. We have a cubic
Oh,
foot.
man, it looks
equaling
baller.
728. I want to call your
That should be
attention to
fun.
the 1 square yard, which is 1,296 inches. As it turns out, we could stick a zero on the end of that, and we have 12,000.
Oh, nice. Oh, with your grandma, that's a great idea.
Awesomely important.
It's a really expensive area, fancy place,
in
man.
terms of some of the great cycles that affect this planet.
Yeah, it looks fancy.
That's what we're going to be getting to. Geometry, everybody knows that a circumference of a circle is divided into 360 degrees, and that 360 degrees of arc, because each degree is subdivided into minutes of arc. There is then 60 times 360, as it says there, 21,600. And then you'll notice that 21,600 minutes of arc equals 1,296,000 seconds of arc. That's a mighty fine subdivision of a circle that would be used mostly by astronomers to measure the motion of distant stars. But notice that number, 1,296,000, and you'll see that it's the same number, just raised by 3 orders of magnitude as the number of square inches in a square yard. Okay, now another thing you might notice about most of these numbers from 1440 to 8640, 43,200, 144, 1728, 36, 1296 is that they all Kabbalistically add up and reduce to a single digit 9. Notice that all of them, pick any one of them, other than say with the exception of 24, but 1440 adds and reduces to a single digit 9. 1296, you'll notice the same thing, 1 and 2 and 9 and 6 is 18, which adds to a 9. Okay, so if you're taking notes, write these down or make mental notes of these numbers, because these are the numbers we're going to be encountering now as we progress through this journey here into the hidden mathematics. So we will start by looking at how some of these same numbers and other numbers are associated with the measures of geometry. And here we have what I refer to as the alphabet of sacred geometry. And these are the simplest forms. These are the polygons. You have a circle, which is actually not a polygon, but we have an equilateral triangle, a square, and a pentagon. And each of these can be measured by the number of degrees that determine the angles of the sides. So for example, we look at a circle, which is just a special case of an ellipse with eccentricity of 0. We've covered this already, so let's go right to the equilateral triangle, and we'll see it's 60, 60, and 60, which equals 180 degrees. Again, notice that we've got the number 9 recurring. We go to the square, which is 4 times 90 degrees. The total number of degrees defining the square is 360, the same as the circle, the same as the measure of a circle. And we measure the polygons by essentially measuring the angles of the vertices or the corners. So then likewise with the pentagon, each of the angles between successive edges is 108 degrees. So you multiply the 108 times 5 and you get 540. Again, notice, everything adds up to 9 for some strange reason. 108 is going to turn out to be a very important number. It's a lunar number, as you're going to see. 108, anybody know what metal has an atomic weight of silver? Atomic weight of 108? Yes, that's right, it's silver. Very good. All right, so let's get into some of the solid. Tetrahedron is this form right here, and it's composed of 4 of the equilateral triangles. So we have, as it says here, there's 4 triangular faces. 4 times 180 is 720 degrees. That is the total angular measure of this particular geometric form. This is known as one of the Platonic solids, or regular polyhedra. Polyhedra means multiple faces, and the regular polyhedra is the family of 5. There's only 5 that have the same shape or the same polygonal face. In this case, the equilateral triangle. And then we will move on to the cube, and the cube is 6 faces, and they're each square, and we saw that each of those square faces had 360 degrees, 6 times 360. The important thing is to grasp that the total number of degrees in this form is 2,160. 2,160. We're going to find out that that number actually turns out to be pretty significant in the measure of other parts of time and space. Then we'll go to the octahedron, and it has 8 triangular faces. This is our octahedron right here. And they're all, you'll notice that so far the tetrahedron and the octahedron are both composed of equilateral triangular faces. And essentially, if you look at the difference between the tetrahedron and the octahedron, you could just imagine it if we could take the tetrahedron and split it along an edge and insert a 4th triangular face, it would cause it to flatten out somewhat, and it would give us the top half of the octahedron. And likewise, we could insert a 5th equilateral triangle in here, and it's going to give us the icosahedron, which I'll show you in a minute. If we tried to insert a 6th one, though, we discovered that the whole thing flattened out into 2 dimensions, so that wouldn't work as far as enclosing space. So in any case, notice we're seeing a recurrence of this number that we saw, 1440. Remember we saw that number back right here, the number of minutes in a day. So let that relationship sink in. The number of minutes in the time that it takes our Earth to spin exactly once on its axis relative to the sun happens to be the same number of degrees that define the octahedron. And that's actually what we're talking about then when we're talking about a tropical or solar day. We're talking about exactly one rotation of the Earth on its axis relative to the sun. Okay. Then we have the icosahedron, which is 20 faces, all equilateral triangles. You can see if you look at the vertex of this thing, you'll see that there are 5 faces clustered around each vertex. So if we were to split an edge, insert another triangle, what it would happen is it would flatten out into a hexagon, a flat hexagon, with 6 equilateral triangles about its center. In any case, there are 20 of these triangular faces. 20 times 180 is 3,600. So again, we have one of our 9s, and then our final is our dodecahedron. My favorite shape. This is what Plato referred to the dodecahedron as being the shape of the universe itself. The dodecahedron, you'll notice, has 12 faces, 20 vertices, whereas the icosahedron has 20 faces and 12 vertices. So they're duals of each other. We could actually suspend this icosahedron. If the dodecahedron was hollow, we could put it inside. We would discover that each corner of the icosahedron coincided with the center of the pentagonal face of the dodecahedron. Okay, each pentagonal face, as we found out, each edge was 108. 5 times 108 is 540. 12 times 540, as it says, is 6,480. So again, we've got the number 9 redundantly occurring over and over again in these measures. Okay, 6,480 turns out to be a critically important number as well, as you're going to see as we proceed along here. Oh, and then we have the star tetrahedron, which would be 2 tetrahedrons interlaced, and I don't have one of those today, but if you can picture a tetrahedron like this, and then one like this, interlaced, it gives you this, what's known as sometimes the star tetrahedron, or the stellated octahedron. It is composed of 2 tetrahedrons, each of 720. So here again now you're seeing the repetition of this same number, 1440, being the measure of the star tetrahedron. Okay, so now we're going to talk about time measures. The first thing we're going to look at is astrological time cycles. I don't know how many of you have studied astrology, but in this particular scheme of time, the total duration of the precessional cycle, which is 25,920 years, this is the motion of the Earth on its axis like this, or you could think of it like this. The axis of the Earth actually forms sort of an hourglass motion, a long, slow period of rotation. It's you could consider Earth's third motion, next to its first motion, which is the daily rotation of the Earth on its axis, its second motion, which is the orbit of the Earth around the Sun, and its third motion, which is the precession of the Earth's axis. The diurnal or daily rotation of the Earth on its axis gives us the day-night cycle, which is obviously of critical importance to our life down here on Earth. The orbit around the Sun also is likewise of critical importance because that's the yearly cycle. The third motion is what the ancients referred to as the Great Year. And it's been measured by astronomers at slightly over 50 seconds of arc of motion per year, which actually puts the astronomically determined number slightly less than this one. But we don't know that that's necessarily constant for the whole cycle. In any case, the ancient number that was typically attributed to this great year cycle was 25,920 years. That great year was considered to be analogous to our annual year. And just as the annual year was divided into 4 seasons of spring, summer, winter, and fall, likewise the great year was divided into 4 great seasons, symbolized by the 4 fixed signs of the zodiac: the bull, the lion, the eagle, and the man or the angel. If you divide 25,920 by 4 to determine the duration of each season, you'll discover that it's 6,480 years, which is interesting because 6,480 6,480 years, as you recall, was the total measure of the dodecahedron. So here we have this same number linking the measure of space in terms of the dodecahedron, 6,480 degrees, and the season of the great year, which was considered to be profoundly important to ancient cultures all over the world, who had various ways of representing this fourfold division of cyclical time. All right, then we have, from the ancient Chaldeans, we have what was known as the Saros cycle, which was 3,600 years. So we see a repetition of that number. The 3,600, if you recalling and are taking notes, is the number of degrees measuring the icosahedron. Then we have the decans. You'll notice that a Platonic month, which is 1/12 of the great year, right there. You divide that number by 12, you get this number, 2,160. And that number, you may recall, depending on how good your memory is the number of degrees measuring the cube, 2,160. And then you'll notice the 2 decans of the ecliptic, or 20 degrees of the ecliptic, is 1,440, the number of degrees in the octahedron. And 1 decan, or 10 degrees, or for any of you who've studied astrology, you know that the decans are important to astrological determinations. 1 decan of 10 degrees then takes 720 years. And so here we have all 5 of the Platonic solids represented in these particular time cycles. And over here, I'm going to mention that ancient cultures all over the world used to run 2 calendars successively. A secular calendar, which is typically like our modern calendar of 365 1/4 days, and then they would have a sacred calendar of 360 days, and 5 days intercalated, they would call it. Typically, they would do, whether it was the Greeks or the Egyptians or even the Mayans, ancient cultures all over the world had similar traditions of setting those 5 days aside, and they were considered to be unlucky. And so no work, no activity, nothing. Nobody ever tried to do anything on those days. They would just take those days off. 5 days off, then they would resume again and pick up their sacred year of 360 degrees. Now the Sumerians had a belief that the year was once actually 360 days in length, and that somewhere along, as a result of some cosmic catastrophe of some undefined sort, the year was lengthened by 5 1/4 days. And so the Sumerians, who are the first known culture to mathematically divide the circle into 360 degrees, it is believed that one of their motives for doing so was they believed that that circle then could become a model of the year, and each degree then representing 1 day. So what we have now is a synchrony going on, in that if the year, the idealized or sacred year, is 360 days, then what we have, if you actually picture it, is that the Earth is describing a circle in its orbit, but then in each degree of motion around that circle, it's turned once on its axis. So what we have there is a synchronization of this cosmic motion representing these numbers. So in any case, the ancient cultures would reckon time measure by 360 days according to the sacred calendar. And by doing so, they could then divide that 360 days of the sacred year into subdivisions such as this right over here. And we'll just run through that very quickly. You'll notice that 1 decan turns out to be 10 days within the sacred calendar, and that's exactly 14,400 minutes. So here we have the same numbers recurring again. You'll notice though that the symbolism of the number is not lost, or the system of the symbolism of the number is consistent irrespective of its order of magnitude. So in other words, you could say the square of 12 being 144 has the same symbolism as 144 times 10, or 144 times 100 as you have right here, or even 144 times 1,000. Again, referring back to the book of Revelations, there's a verse in there referring to the 144,000 redeemed of the earth. And we'll get to that here shortly. That's an interesting quote, because they have various ways of embedding these sacred numbers into the various traditions. you'll notice that 3 decads, or 1 Platonic month, in the Platonic year was 2,160 years, but in the sacred year of 360 days, again, there's that 43,200. So, and go down here, the 1 Platonic season of 6,480 years, 129,600. So if you're taking notes and writing these down, you're going to find it, you're writing down the same numbers over and over again, simply raised to different orders of magnitude. Okay. This is just a little graphic that depicts this precessional motion that I'm talking about here. This motion right here, that is generally assumed by most astronomers to be primarily induced onto the Earth by the moon, secondarily by the sun, and then also a contributing factor by the planets. So it's almost, you could almost think of this precessional motion of the Earth's axis as being the vectoral summation of all the gravity forces of the solar system acting on the Earth, causing it acting. See, when the planet rotates on its axis, and this is a critical factor, as it rotates on its axis, it spreads out towards the middle. Its equatorial diameter is greater than its polar diameter, and that, in fact, is critical to the Earth maintaining axial stability, so that it's not doing this in its orbit around the sun. Because if it was doing that, it's likely that higher life would have never evolved in the first place. But due to the fact that it spins, it spreads out so that the diameter of the equator is 26 miles greater than the diameter of the pole. The sum total of all the gravity forces impinging upon the Earth from moon, sun, and planets acts upon that bulge as if it was a flywheel, and is actually pulling it around. And it's that leads to the great year. And what it does is, over a period of half the great year, 1 million or 12,960 years, is it reverses the seasons. So that if we were able to jump in a time machine and go back 12,960 or ahead 12,960, we would find that everything was reversed. If we would keep the same Gregorian calendar in place, the seasons would have been reversed, so that winter would be July and summer would be, in fact, and then what we would see is that hemispherically, like we know that when it's winter in the northern hemisphere, it's summer in the southern hemisphere. Well, those seasons would be reversed. They flip. It's a back and forth. It's an oscillation between the two hemispheres of the Earth over a period of 12,960 years. This shows the wheel of the great year with all of the ages, the astrological months as they're known. And if we were to place ourselves right at this position right here where it says 0 years BP, BP means before present, and it also is 25,920 years. So what has been happening is that the vernal equinox, a hypothetical point in space occupied by the sun, when day and night are the exact same duration, that vernal point is moving through space as a result of this axial motion of the Earth. And ancient peoples would go to great lengths to try to observe and predict that motion. So they would set up structures, oftentimes on a very large scale, that would be oriented to certain points in space, so that one could, from certain vantage points, such as the center of a ringed megalithic structure, for example, or the center of a temple that had an axial orientation to a certain point on the horizon, one could make minute observations of this slowly shifting vernal equinox, or, for example, the solstices. The vernal equinox and the solstices are two lines in space that are at right angles to each other. I'll show you a graphic in a minute. But in any case, as we go around this wheel, this great wheel here, this wheel of this cosmic wheel, what we're going to see is that each of these is a zodiacal sign. We have here Pisces, we have here Aquarius. So now the vernal equinox is poised. It's moving out of the star constellation of Pisces, moving into the star constellation of Aquarius. And so we say that roughly for the last 2,000, or if we want to be precise, 2,160 years, the vernal equinox has been transiting the constellation of Pisces, and therefore we've been in the Piscean age. Prior to that was Aries. Prior to that was Taurus. We find that the beginning of modern recorded history goes back to the Taurian age. We can essentially express all of recorded human history between the latter part of the Taurian age through the age of Aries, the age of Pisces, and now into the age of Aquarius, right? Okay, if we go back, we'll notice though that the numbers here are the same numbers, the same family of numbers we've been looking at here. 2160, 4320, 6480, 8640, 10,800. We saw the number 108. I called your attention to that when I was asking you what was the atomic weight of silver and which metal, which astronomical object is silver associated with? The moon, yes. 12,960 puts us exactly on the opposite end of the equinoctial axis, and then we see at right angles to each other we have the autumn spring axis, and this is the summer winter axis, and they're at right angles to each other, and the whole thing is rotating. You've got a picture that this propeller is rotating counterclockwise, so that in 6,480 years Taurus will have moved down to the 0 point. Okay, we've seen this. So this is just a recap of those same numbers. And you will notice 8640, the number of seconds in one day. You'll notice that in a half a day, 43,200. Well, if you go back to the dawning of the age of Aries, 4,320 years ago. And these are just more interesting ways that these numbers show up. If you take 25,920 seconds and set each second corresponding to 1 year of the great year, you'll discover it's exactly 432 minutes. 25,920 hours in turn is 1,080 days. And 25,920 days is equal to 72 years in the sacred calendar, which is interesting because I think most determinations of the average human lifespan right now in history is about 72 years. So you could think of a human lifespan as being equivalent to 1 day of the great year. There's an interesting proportional relationship going on there between the total precessional cycle of 25,920 years and one human lifetime. In the Vedas, they had various ways of encoding references to numbers. Let the Brahman hear the praise we utter. This hath the four-horned buffalo emitted. 4 are his horns, 3 are the feet that bear him, his heads are 2, his hands are 7 in number. Notice 4, 3, 2, raised to the 7th power, gives you the number of years in the ancient Vedic time span, the Kalpa, 4,320,000,000 years, which I find to be suspiciously close to the modern estimate for the age of the universe, which is about 4.5, or the age of the earth rather, which is about 4.5 billion years. So this was one way they had of encoding or embedding references to these sacred numbers in the Vedas. And this is probably some of the oldest writings extant where this canon of numerology is presented. In ancient Sumeria, from the various writings of historians like Berossus and others, and from the Sumerian clay tablets, we're able to find that there were references to 10 pre- or antediluvian kings. What does pre-diluvian mean? Before the flood, right. So they had this belief that there were 10 kings reigning before the flood. And you'll notice the numbers that they ascribed to each of the kings, the reign, those numbers now should all be becoming familiar to you. You've seen a bunch of them already. There's 43,200, 64,800, 36. You'll notice 64,800 is presented twice, actually 3 times. The total, though, 432,000 years. That's a long span of time. Do you think they meant this literally, or is this strictly symbolic and figurative? Is it possible that the king could have reigned for 36,000 years? I tend to think it was symbolical, but it is interesting that one of the universal traditions from ancient cultures is that before the flood, and all the cultures from all over the world recognized that there was a great flood or even floods that decimated humanity at various times. But they're all pretty much in agreement that prior to the flood, the human lifespan was much longer than it is today, which I find we've all heard about Methuselah living to be 969 years, right? Or Lamech being 777. It seems that they had, in the biblical ages, they seem to have lived about an order of magnitude greater than our modern ages. Which, considering, from my perspective, the things I'd like to get done in this lifetime, I would need at least that many years. In the Vayu Purana, which is again one of the Vedas, we find verses like this: 360 years, according to the human calculation, constitute one divine year. Wise people know that there are 4 yugas in Bharatavarsa. The first one is Treta, then follow Treta, Dvapara, and Kali. Probably some of you have heard of the Kali Yuga that we're supposedly in right now, and supposed the age of darkness and the age of ignorance. But you'll notice that they reckon time. They have another. The Vedas recognizes a sacred year that they call, or a divine year, which is 360 of our years. Okay, now here's a tabulation of the Vedic ages. And you'll notice, we'll look first at the total in human years, and we see that the Kali Yuga, the shortest, is 432,000. Then we go to 864,000, 1,296,000, 1,728,000, and 4,320,000. You'll notice that the total, or the Mahayuga, the Great Yuga, is 10 times the length of the Kali Yuga. And that's because you'll notice that the Dwapara is twice, the Treta is 3 times, and the Satya is 4 times. So taking the original term, doubling it, then tripling it, then quadrupling it, adding those together will give us 10 times the number we started with. But again, notice the number that the Vedic ages begins with. 432,000 is the same number that the Sumerian king list ends with. So it's almost as if we have 2 different traditions but one system. And we see that the Sumerians preserved knowledge about the subdivisions of this Yuga time of 432,000 years, and symbolize these subdivisions by the reigns of these 10 pre-Diluvian kings. And then we can see that once we get to 432,000 years, at that point the Vedic cycles kick in, and then we have these that follow. And using the divine year of 360 years yields this column of numbers. And then when we put the duration into human years, it's interesting, each of the yugas, such as the Kali Yuga, they were all believed to have a period of transition into the age, then the age itself, and then a period of transition out of the age. And so basically what they did was they took the total age. You'll notice here the relationship between the Kali Yugas, the 360,000, and the Sanya, which was the transition in, and the Sanyamsa, which was the transition out, are each 1/10 of that, adding up to the total of 432. But you'll notice that we've got the same recurring numbers again. Now there's 144,000 right there. And then we have that raised by another order of magnitude. So you see how these same numbers are recurring over and over again. And I would suggest that there's a pattern emerging here. And I know that for a lot of people, first time they are confronted with this kind of information, sometimes it's almost too mind-boggling. You know, what the heck does all these numbers mean? It's just too many numbers to sort out. But what you realize once you start studying them is that each one of them is kind of a mnemonic, because each number has a whole collection of phenomena that's associated with it. And it's still in use today. I mean, how many people, everybody should know that a square foot is 144 square inches. I mean, anybody who's a builder, a crafts person, an artist should know basic rules of measurement. The Mayan world ages. Now you notice there, do we see similar numbers? The Baktun, 144,000 days. So it's almost like they had the same numbers, but they're now representing smaller cycles. But it's the same numbers representing these cyclical periods within nature. Atun is 360 days, and that was the sacred calendar that we find all over the ancient world. And then they had the 5 days added to that, the 5 unlucky days. So again, we see the same numbers being repeated redundantly throughout these various traditions. Sacred numbers embedded in solar system architecture. I'm only going to show you a few examples of this in order to convey to you the idea. The solar orb. Well, if we measure that, we discover its radius is 432,000 miles, which of course means that its diameter is 864,000 miles. So notice that we measure the sun according to the human measure of miles. And by the way, what is the origin of the mile unit that we use? Anybody know? Origin of the mile? Origin of the mile, it comes from the Latin word mil, which means 1,000. So it's talking about 1,000 something. What would it be talking about? 1,000 what? 1,000 paces that average 5.28 feet in length. It actually goes back, we know that Romans were using a mile that were 1,000 paces, and they would lay out, Rome, for example, had a city center, and everything was measured outwards from that city center according to paces. And those paces were 1,000 of them gave the Roman mile. The Roman pace was a little bit shorter than the British pace, which is where we get our mile from. Our mile, in fact, interestingly, and I'm going to show you a diagram of this shortly, Stonehenge is 105, the outer ring of the Sarsen stone circle measures right at about 105.6 feet, which makes it 1/5 of a mile, or 1/50th of a mile, I'm sorry. That and several other numbers that we find in megalithic structures in ancient England suggest that the mile was actually a unit of measure that was being used as long ago as 4,000 years or longer. And we're still using it today, the same unit of measure that could have been used 4,000 years ago. And for that reason, and once you begin to get into and understand the sacred basis of our ancient metrological or measuring systems, you'll realize that if we convert completely over to the metric system, we're going to lose something very, very profound. All right, remember what was the length of the Kali Yuga? 432,000 years. What was the length of the Dwapara Yuga? 864,000 years. What was the length of a Platonic month? 1/12 of the great year. Anybody remember? 2,160 years, right? The same number of degrees that measure the cube. All right, what are we looking at here? Anybody recognize that? Look familiar? The moon has a radius of 1,080 miles, which gives it a diameter of 2,160. Remember I said that 1,080 or 108?
Wow, that's really wild.
It's double. 2,160 was a lunar number. See, this is a clue to you now. There are several references, for example, in the Sumerian tradition describing the ark built by Sisyphus, which is being described as a cube. It makes no sense. You think, what kind of a ship is it that would be described as a cube? You know, that wouldn't be very seaworthy, a cube, right? But it's not referring to an actual ship as we think of it. It's referring to the cubing of the sphere. And in this case, the sphere that it's referring to is the moon, which was symbolically considered to be an ark to many of the ancient cultures that believed that the earth was periodically destroyed by great catastrophes. So we have the number 1,080, and we have the number 2,160. And then we have the earth. Yeah, that's the earth. And again, because of the spinning of the Earth on its axis, we have this difference between the polar diameter, 7899, or just thinking round number, 7,900 miles, and the equatorial diameter, 7,926. So that creates a 26-mile difference. And thank you for that 26-mile difference, because life on Earth would be a very chaotic affair without that bulge. We see that the diameter of a sphere with the same surface area as Earth is 7,920 miles. And also the diameter of the Earth, when you take it from, if you slice it through the Tropic of Cancer through to the Tropic of Capricorn, that diameter also is about 7,920. So we use 7,920 as the sacred number to represent the Earth, because even though the Earth varies considerably between equatorial and polar diameters, we find that at a very significant piercing through of the Earth's diameter from one tropic to the other tropic turns out to be 7,920 miles. We also find that if we take a perfect sphere that has the same area, the same surface area as the Earth actually has, its diameter would be 7,920 miles. So that's the number we use for the Earth, which means that its radius is half that, or 3,960. And in most books you read, astronomy and so forth, when they're talking in round numbers about the radius or the diameter of the Earth, these are the numbers they use. 7920 and 3960. Okay. Now, what I've got here is evidence for advanced geodetic knowledge in archaic times. What is geodesy or geodetic knowledge? Geodesy is the determination of the size and the shape of the Earth. Early in the 19th century, such knowledge was acquired by extensive land surveying and triangulating over large tracts of the Earth's surface. Since the 1970s, orbital satellites have provided the most accurate picture of the Earth's exact size and mass distribution. Any advanced comprehension of the larger picture of our planet as a suitable abode for the evolution of higher life requires knowledge of its size and shape.
Big Angel, what's up, man?
Determines G, the gravitational
Holding down those nuclear plants, bro.
Bulge is an integral
How's it going, man? How you doing, bro? How you doing?
Acting to impose rotation and orbital stability on Earth as it wheels about the sun. The relevance of these two basic factors to the evolution of life cannot be underestimated. Ancient master builders understood Earth's fundamental geodetic parameters on a level not equal to
No, I'm not gonna do that. You said to do it last time. I remember you did push me up from, what was it?
Probably the most
115 to 135, I think, or 135 to 155 or something.
And there's been lots and lots of
I'm glad you did, man.
what the
But no,
form
I'm
or
glad.
function of the Great Pyramid was.
I'm glad with a 165. I'm doing 2 reps instead of 1 now.
Pretty out there.
I'm adding a
Some
rep.
of it I think is pretty
So instead of weight,
abstract.
I added a rep.
What I've always thought does
What's
make
up,
the
bro?
most sense and has the greatest credibility is the pyramid is essentially a model of the
So
Earth
I'm doing like
or the
2
Earth.
instead of 1, which it's like massive. It's
The thing
doubling
you
it.
have to understand when you're looking at the measurement of the Earth in terms of its size and shape is that we have lines. Everybody knows latitude and longitude. Latitude is measured north and south of the equator. Longitude is the measure around this way. Parallels are lines that run that parallel to the equator. And traveling along one of the parallels, we would be displacing ourselves longitudinally. But parallels actually measure, you can see that this parallel here, this is probably the Arctic Circle. It looks to me like about 66.5 degrees north. So it is parallel to the equator, right? So depending on what parallel you are, every line of latitude, north and south, has a corresponding parallel. And you know that from the equator to the North Pole is going to be 90 degrees. And likewise from the equator to the South Pole is going to be 90 degrees of arc. Then in turn we have meridian lines, which are lines that run north-south, but actually measure distances east and west. So that if you traveled from one meridian to the next to another meridian, you would have traveled from east to west. every point on the surface of the Earth has a local meridian. We have a local meridian here, and it's basically the way you would find it is if you walked out here. I believe this is generally south, isn't it, this way? So if we went out here and we looked exactly south and exactly north, and then the zenith overhead, the point 90 degrees up from a flat horizon, and we struck an arc from the south point through the zenith point to the North Pole, that arc would be our local meridian. And as the Earth turns under that local meridian, we measure all astronomical motion relative to our point on the surface of the Earth with respect to that local meridian. Now, you'll notice that as you go through the parallels form virtually perfect circles. The meridian lines, on the other hand, are not circles because of the flattening of the Earth. Because of the expansion of the equator, you draw a line around it this way, and cut the Earth this way, it is not going to be a circle. If you cut it this way, it will be a circle. Okay, that creates very subtle differences in geometry. When you're measuring a meridian line north to south, what happens is that as you travel north away from the equator, if you were going on a perfect sphere, then each degree of latitude north would have the same distance. But it's not a perfect sphere, it's flattened. So as you're moving towards the North Pole, the Earth is actually flattening out. The Earth's radius is shrinking. So it's flattening out. What that means is that to traverse a degree of arc, you have to travel further as you get away from the equator towards the North Pole. Okay, I'm explaining this because you've got to understand this to see how the ancients actually understood, how they demonstrated to us that they understood the size and shape of the Earth with a high degree of accuracy. So again, parallels are going to be in circles, and you're going to notice that the biggest circle is going to be the equatorial circle, and as you travel towards the poles, those circles get smaller in size. So therefore, if you took the meridian lines, which would be the dotted lines, the distance between, say, 1 degree of meridians at the equator is going to be greater than that distance between the same two meridians, say at our latitude here in Atlanta, which is about 34 degrees north, or further north. As you travel further north, those meridian lines converge until you would get to the North Pole, and then they meet each other and have zero distance between them. Okay. This is taken out of the Smithsonian meteorological tables, and what we're looking at here, without belaboring this, is you'll notice latitude 0 degrees, and you go through up to 90 degrees. And what this is showing is if we look into statute miles right there, this says length of 1 degree of the meridian. So this is the line from equator up to the North Pole. Well, if you look at the first number, which, let's see if we can zoom in here, you'll notice that at 0, when you travel, leave the equator and go to the 1st degree north latitude, you've gone 68.703 miles. But if you look down here at the very last one, when you traverse that last degree from 89 and you finally get to the North Pole, you've traveled 69.4 miles. So those degrees have stretched out. Okay. Now this is important to understand how the ancients were able to demonstrate to future generations that they understood the size and the shape of the Earth. And then we have one length of 1 degree of the parallel. If you notice right there, I don't know if you can read it from out there, but that says 69.172 miles. So think of a circle going around the Earth's equator. You've traveled 1 degree, 1/360 of that distance around. You've gone 69.172 miles. Let's go halfway up from equator to North Pole, which would be 45 degrees, and we see right there, you've gone 49 miles. Then when you get up to the pole itself, when you're 1 degree away from the North Pole, you only have to go 1.2 miles because those meridian lines have converged. So now, the thing to grasp here is that if we're measuring the size and the shape of the Earth, that's going to vary depending on where on the Earth we're making those measurements. This is important because what we discover is that the ancient peoples knew this and incorporated it into their architecture so that they would derive units of measurement that were ultimately based upon the size and shape of the earth where the structure was being built. Now let's take the most prominent one. Before we get to that, this is geodetic data, and you'll notice here we've got going back to 1830, which was the first attempt in modern times to determine the size and shape of the earth. And let's go, since that's meters, let's go to something we'll recognize, miles. We're talking about the radius here. And you'll notice as you're coming down through here, we get to these last two, World Grid System 72 and Geodetic Reference System 80 are the two that were determined by satellite measurements. And you'll notice that as we come through here, we've got a polar radius in miles and an equatorial radius in miles. And then we have the difference in the two radii right here. And we assume that as we've come through, we're progressively getting better and better at measuring the size and shape of the Earth. And finally, with satellite measurements, we're getting down here, and we've determined that the polar radius, for example, 3,949.8934, 3,949.8948. What does that translate into? Well, let's see. In terms of feet, that's a difference of 250 feet roughly between between these two measurements. In other words, between the first satellite measurement in 72 and the second one in 1980, the difference was about 250 feet, say.
The history of man may be far longer and stranger than we think. The Great Pyramid may indeed not fit in with what we believe about the past and the nature of the world. Thousands of years ago, someone measured the earth with remarkable accuracy and recorded this information in the dimensions of the largest and possibly the oldest stone building on the planet, William R. Fix.
Generally, the age of the pyramid is given around 4,200 years, roughly about the same age as the Sphinx. Some of you are probably familiar with the redating of the Sphinx by several geologists, primarily Robert Schoch from Boston University, who has studied the weathering of the limestone composing the Sphinx and the surrounding quarry that the Sphinx is situated in, and has determined that the rock has been severely weathered by water erosion. And of course, the Giza Plateau has been desert for the last 4,000 years, so it's not likely you're going to find severe water erosion on the Sphinx if it's only 4,000 years old. In fact, so severe is the water erosion that it's likely that the Sphinx is probably tens of thousands of years old. However, Robert Schoch, in most of his public presentations, usually places it at 7,000 to 9,000 years, but he's told me personally he just uses that because he's deliberately being very conservative because he's in the academic community, but he's perfectly willing to believe that could be much older than that. And I've discussed the extent of the water erosion with him and discovered that he actually hasn't looked in depth at the comparable studies of rates of limestone weathering, which I spent a couple of months about 10 years ago studying, going around to various places where there were limestones and where you could see examples of limestone that had been weathered, and had looked at, read the literature that had been done on limestone weathering, and had concluded that, it would be a minimum of 20,000 years worth of weathering. And that's a minimum if you took the Sphinx and set it in a climate with rainfall, like say we've been having for the last 3 months, which would average out to about 45 inches a year. Even with rainfall like we've been seeing here in Atlanta in the last 3 months, it would take the Sphinx a minimum of 20 to 30,000 years to get the level of erosion. That raises the question regarding the Great Pyramid. Could it be as old? And I see no reason why not. Problem here, though, is that the Great Pyramid was once covered in white limestone casing stones, highly polished, and according to Arabic traditions, pretty much all the Arabic traditions and legends about the Great Pyramid concur that the outside of the pyramid prior to the stripping of the casing stones was covered, completely covered in hieroglyphs. And one, it just boggles one's mind to contemplate what might have been written here. But clearly I have a hard time imagining a greater act of vandalism in all of history than the stripping of those stones. In fact, there had been efforts to get into the pyramid up until the time of Al-Mamun, which was I think around 1200 AD, but they were completely ineffectual. And then somewhere around the 12th century, I've forgotten the exact year, there was a great earthquake in northern Egypt. And it caused most of the buildings in Cairo to collapse. And it also loosened some of the casing stones on the pyramid, which allowed them to get in and pry those stones loose from the top. And all of the stones were then stripped off, and that indurate high quality limestone was stripped off and recarved and used in buildings to rebuild Cairo. So I've often thought there's probably temples somewhere in Cairo where maybe some of those original stones are still to be found with inscriptions intact. Of course, I have no idea, but I've oftentimes thought, wouldn't that be cool? Anyways, they stripped off the stones, and as they stripped them off, there was a lot of rubble that fell down and buried the bottom of the pyramid, which turned out to be a good thing because it buried the bottom casing stones from those bottom and preserved them. And so from those, you know, the various researchers could determine what the original exact angle of the pyramid was. And according to most calculations, it was around 51 degrees, 51 minutes, 14 seconds. I don't know if that level of accuracy is credible or not, but 51 degrees, 51 minutes would be. And from there, we can then determine what the geometry of the pyramid would have been and what its original height would have been simply by taking the tangent of that angle, 51 degrees, 51 minutes, and knowing the base length, one could calculate what the original height would have been to a high degree of accuracy. So that's been done by, 4 or 5 different people over the years. J.H. Cole in 1925 did what's considered to be the definitive survey of the Great Pyramid. He was a professional surveyor who did a very meticulous survey after they had just cleared away all of the rubble, and he had access to it. He did it under contract to the government of Egypt. The numbers that I'm about to show you here are mostly derived from his survey. So what we have here is here's some of the original casing stones, and they sit on what's called a socle, which is this base, which was measured to be 55 centimeters in thickness. And of course, you got to bear in mind that this original slope casing stone, it wasn't stepped like that originally. It was a smooth profile. And okay, so here you have, of course, here you see that the casing stones were damaged by the rubble falling down, but enough of them were still intact that one could make this accurate determination of the original angle. Here's the socle, which is 55 centimeters thick, and it sits directly on bedrock. So it actually, what it does is it creates 2 ways that one could measure the height of the pyramid, either with or without the socle. There's also 2 ways of measuring the base. This is a reconstruction from 1991 work on pharaonic stonemasonry. And this shows that outside the corners, which was the core masonry, there are these sockets. And I found one picture showing a socket. This is showing one of the sockets that's still there, that sits outside the core masonry. But based on those sockets, they were able to reconstruct what the original base of the pyramid would have looked like. So here would have been the 51 degrees, 51 minutes, coming down, sitting on the 55 centimeter thick socle here, like this. Well, what this did was it gave 2 ways of measuring the perimeter of the pyramid's base. One could be measured from this point up on top of the socle. The other could be measured from down here that included the socle. So what you ended up with was 2 ways of measuring the pyramid's base. Well, which one was the correct one? Well, they were both correct. I think that they were actually intending to embody in there that there were 2 ways of measuring the pyramid's base. So what we have is the length of the base on the socle, which is the shorter of the 2 up there. It was varied from side to side. You'll notice 755 at the smallest to 756 just over at the largest. So there was some variation There's probably a reason for that variation, actually, but we won't get into that because it just gets too technical for what we're talking about today. But the total of those measured around the four sides would be 3,023.139 feet. If you're taking notes, that'd be a good number to write down. Okay, so now let's see what the measure is around that includes the socle or the base. And we see that each side is roughly 5 feet longer, 760 to 761. Each side again is a little different, but we get a total of 3,043.433 feet. Okay, so I'm going to over here, I'm going to write down a few numbers that we saw through our radius of the moon, diameter of the moon, radius of the sun, diameter of the sun, number of seconds in a day would be 43,200. Number of seconds in a half a day, number of seconds in a full day, 86,400. What were some of our more other numbers? Oh yeah, 1440 was one, 7920. Diameter of the earth, just so they're up there in front of you, we can refer to them as we go on here. All right. So here is profile of the Great Pyramid with a 51-degree, 51-minute angle. To make it easy, I've just rounded off the numbers, 481 feet in height. That would be not including the socle, the base. 755.85, I just picked one to use. And there's our 51-degree, 51-minute angle. And we find that when we measure it this way, it turns out to be almost exactly 11/7. There's some other interesting geometry going on related to the golden section, which I don't intend to get into today because it makes more sense if you're actually studying sacred geometry and you're familiar and you've made these drawings. Because in a sacred geometry class, just like in the old Pythagorean and Platonic lodges, we draw, and then we eventually build models. And that's the way to really get familiar with this and get these numbers as part of your consciousness. I'm not going to get into the connection with the golden section today. When we measure, including the socle, this becomes our height, 482.7575 feet, and the base, 760.9 feet. Okay, those are the numbers we're going to look at for a second. If we look at these are various estimates. We're looking at this one right here, the coal height estimate plus the socle of 21.6 inches gives a total of the height above bedrock of 482.7575 feet. So now we're going to go back to the Earth so we can see how these numbers link the two. We take 1 square degree of latitude and longitude at the equator. And we're standing at the equator. Okay, we know the polar radius now is 13 miles less than the equatorial radius. So what that means is that the circle this way is shorter than the circle. The biggest circle that defines the Earth is the equatorial circle. So a degree of measure on the equator is going to be the biggest, the longest of any degree we measure anywhere on the Earth, the equator. Okay, the north-south is going to be a little bit shorter. And you'll notice right there, we've got 68.7 miles north to south and 69.17 east to west. So it's not a perfectly square unit, is it? It's a little bit distorted. Well, that distortion is totally significant because it's that distortion that is a measure of the Earth's departure from being a perfect sphere. And it's that departure of a perfect sphere that is very significant to us, because without that, again, Earth's orbital stability would be non-existent. Okay, so we're going to divide this up a little bit. If we take this square degree of latitude north to south, longitude east to west, and we look very carefully down in the lower right-hand corner, you're going to see something, a little square. You see that little square? that represents 1 minute, 1/60th of the degree this way, 1/60th of the degree this way. So that's 1 minute of latitude and longitude, all right? We're going to take a closer look at that, and we will see that 1 minute then is 6,045.881 north to south, 6,087 east to west, which is what we expect. The east-west should be a little bit longer, and that's 1 square minute of latitude and longitude. Okay, now we're going to divide each of those lengths into 2. We're going to divide our square minute into 1/4 sections. And here's what I want you to notice. When we do that, we take 1/4 of a square minute of latitude and longitude. Look at our dimension east to west. Look at our dimension north to south. And look at these 2 numbers. In fact, here's an accurate calculation. We take the 482.755 feet, which is the height, and what we discover is that if we multiply that by the number 43,200, which is one of our sacred numbers that we've seen right there, 43,200, it shows up in the Vedas and the Sumerian king lists, etc., etc. If we multiply the height of the pyramid by that number, this is what we come out with, 3,949.83 miles. And notice the difference between the pyramid, which I call the standard polar radius, and World Grid System 72 is only 313 feet over the entire size of the Earth. So we have essentially the pyramid being a scale model of the Earth, the northern hemisphere, at a scale of 43,200 to 1. If we take the pyramid, enlarge it by 43,200, its height, including the socle, now becomes the polar radius of the Earth within 300 feet of our satellite surveys. Then the 2 measures of the base are exactly the difference between the east-west difference and the north-south difference at a square minute at the equator. Now, the skeptic and the reductionist would dismiss this and say, it's just a coincidence, you're just playing with numbers. And I would say, okay, you can believe what you want, but it's there. The numbers are there. You can take the surveys of Egypt by Cole. You can take the geodetic surveys. I didn't make those numbers up, or I didn't fudge them. And what you discover is that when you expand it by 43,200, which, you know, if the number was just some arbitrary number, but it turns out that the factor of expansion turns out to be one of the critical sacred numbers within the ancient systems. And so here we have the pyramid now enlarged by 43,200 times. And another way to think of it is if we go back to this diagram right here, you'll see that as the Earth turns, every half second, it's going to turn this far. So it means that every 2 seconds, the Earth, if you're standing on the equator, in 2 seconds, the Earth has turned 143,200 part of its total orbit. So if you're standing on the equator, in 2 seconds precisely, the Earth has turned in a distance exactly equal to the distance around the base of the Great Pyramid. Now you could dismiss that as being coincidence, but the numbers don't lie. They're there. And so when William R. Fix was saying that someone somewhere thousands of years ago was able to measure the Earth with great precision, and I haven't, of course, elaborated upon all the details of this. I'm trying to give you the overall picture of how it might have worked. Referring back to our geodetic data, if we look at the various ellipsoids that give the polar radius, and then we take each of those polar radii, going from all of these ellipsoids down, the Clark ellipsoid has been the one of 1880, has been the one used in the United States for all non-military and non-NASA related measurements. We still use on a day-to-day basis. If you take a topographic map you know, and you're going out like a 7.5 quadrangle, and you're going out navigating with a topographic map put out by the U.S. Geological Survey, they're using the Clark ellipsoid right there. But you'll notice that when we take these various polar radii lengths in feet and divide them by 43,200, you can see the numbers we get right here. Remember, the height of the pyramid is estimated at 482.7575. So looking at this, what you'd see on here, which one would be the closest? Well, you notice it's come out very, very close to the satellite surveys. Given that it's very and see, when you got to ask yourself, well, why is there a difference between this, the satellite survey of 72, and the satellite survey of 80? Well, if we did another one again with as high a degree of accuracy, we would discover there's still going to be a discrepancy. And the reason is that the Earth spinning through space, there are various tidal forces working on the Earth which are constantly causing it to distort its shape by up to 2 or 3 or 4 or 500 feet. So we never would be able to get more accurate than 300 or 400 feet, because the Earth itself is changing shape. And if we were to measure it every year for the next 10 years, we would get 10 different numbers. They'd all be very close, but they would deviate somewhat, because the Earth itself, there are tidal bulges. You know, where's the moon relative to the Earth? That's going to affect. If the moon and the sun are on the same side of the Earth, that will affect the shape of the Earth up to being several hundred feet measured over the diameter of the Earth. And so it is not amiss to say that the pyramid enshrines a measure of the Earth that could be considered as accurate as those determined by modern satellite surveys. That to me is a very profound insight, because it does suggest that somebody once upon a time was able to measure the Earth's size and shape with that level of precision. And if they were able to do that, what's the implication of that? See, that's the interesting part. Because no primitive culture, using the method of Eratosthenes in about 300 BC in Greece, he measured the Earth and was generally considered to be quite accurate, because he was able to get the circumference of the Earth within about 500 miles of its actual measured circumference by using the methods available to the ancient Greeks. You see, and he was considered to be the first to measure by basically putting a stick in the ground and measuring the angle of the shadow on the longest day of the year over a couple of successive years. That's actually an exercise we do in the sacred geometry class, because it's very interesting how he did that. But he was considered to be, you know, pretty proficient, because he was able to determine that the size of the Earth was, the circumference of the Earth was, you know, 25,000 miles, when it's generally considered to be about 24,800, depending on where you measure. So he was, you know, maybe within 50 miles of the actual dimension of the Earth, but nowhere near as close as the pyramid would be. So again, even if the pyramid was built 4,200 years ago, you know, you got to say who 4,200 years ago had the technology to measure the Earth with that degree of accuracy. Now, that we know of, nobody 4,200 years ago did, or how they would have done it, we don't know. On the other hand, if it turns out that the pyramid could be much older, it leads us back to the, you know, going back 10,000, 20,000 years. This to me is one of those little, sort of like the little crack in the dike, that if you don't keep it plugged, the whole edifice of contemporary knowledge could get swept
What's up,
away.
man?
Because we can't acknowledge that somebody 10,000 or 20,000 years ago was scientifically sophisticated. That was the days of Cro-Magnon man and Aleut living in the cave and so forth. Cave, which is a silly idea, actually. Yes, I'm sure people did take refuge in caves when things got really crazy out here. Yes, I think people did take refuge in caves. But see, this is one of those things, again, that if you accept that it's not just a coincidence, it opens up a whole can of worms that mainstream science generally doesn't want to address. Because we're the epitome of scientific evolution right here and now, right? Nobody before we built satellites could have measured the Earth to within a couple of 100 feet of its actual dimensions. So, given 2 seconds of time, 143,200th part of the daily rotation, A point on the equator will travel a distance precisely equal to the perimeter of the Great Pyramid's base as measured with the socle. In 1/2 second of time, a point on the equator will rotate a distance equal to one side of the base of the Great Pyramid measured with the socle. So here you have a time and space measure integrated into one. The time measure comes in because it's the span of time that the Earth has moved. In 2 seconds, the Earth has turned and moved a distance within a fraction of an inch, being the distance around the base of the Great Pyramid. And so the height of the Great Pyramid measured with the socle is 143,200th part of the Earth's polar radius. So therefore, the Great Pyramid is a model of one hemisphere of the Earth at a scale of 1 to 43,200. So if we took the Great Pyramid and we created a duplicate and turned it upside down, put the two together base to base, that would now give us the polar diameter. One more example, the Parthenon, to show that this geodetic knowledge was still extant down to the time of the building of the Parthenon about 2,400 years ago. This is the east facade. We're all familiar with the Parthenon. It's almost as well known as the Great Pyramid. Well, if we measure its base in the manner that I'm showing here, it's 100 Greek feet. So how long was a Greek foot? A little bit longer than our modern foot of 12 inches. Before we do that, let's look at the dimensions of the Parthenon. Based upon our American feet that we use, the east facade is 101.2957 ... feet. So if we divide that by 100, we get the length of the Greek foot, which would have been 1.0129, etc., of our American, which are actually the British feet. Okay, I better write that down so we don't forget it. That's good enough right there. There's the width of the Parthenon measured in our American feet. And also notice the latitude of Athens, where the Parthenon is located, is 37 degrees 58 minutes north. And I'm going to write that down, 37 degrees 58 minutes. So it's almost 38 degrees north. And here we have, based upon numerical and proportional relationships augmented by extensive analysis of ancient structures, artifacts, and texts, Stachini, who was considered one of the preeminent metrologists of the 20th century, he determined various lengths of the foot. He came up with the Greek foot of 1.0114064. Now notice here we've got the width of the east facade of the Parthenon divided by 100 gives a Greek foot of 1.0129 for a difference of 0.018 inch in excess of the length of the Greek foot as calculated by Stachini. It is acknowledged by architectural historians that the Parthenon was originally built to be 100 Greek feet in width. This would have made it equal to 101.14 English feet when built. Now if we go back to the length of 1 degree of the meridian, and we look right here at the latitude of Athens, we find something very interesting. Length of 1 degree of the meridian, the latitude of Athens, is 68.962 miles, or 364,121.647 feet. So if we take that number, divide it by 60, it gives us the length of 1 minute of meridian arc. Then we divide that meridian arc by 60, it gives us 1 second of meridian arc. And notice what 1 second of meridian arc is, 101.1449 feet. So 1 second of meridian arc at 38 degrees north latitude, given the international ellipsoid and the Clark ellipsoid, you'll know here that it's exact. So in other words, what we have there the total difference in length of 1 second of meridian arc at 38 degrees north latitude and the east facade of the Parthenon is 0.05 inch. But again, that's for 38 north latitude. It's actually at 37.50. So if we make that adjustment of 2 minutes of arc south, this 0.05 pretty much just disappears into nothing. So what we have is the Parthenon, again, maybe coincidence, but here we have the Parthenon being precisely 1 second of arc of the Earth's circumference at that latitude that it's placed. Now again, that implies somebody was able to measure the Earth with incredible precision, if this isn't a coincidence. And I think the burden of proof would be on the person who tries to dismiss this as being coincidental. Because the two examples I've shown you here could be multiplied many times over. We haven't even talked about the Gothic cathedrals, and the fact that every Gothic cathedral was built with its own cubit. And that cubit is based upon a multiple or a subdivision of the meridian length at the latitude that the cathedral was built. So you could take many examples of this. And what I'm suggesting here is not necessarily that the Gothic cathedral builders of 800 years ago were able to measure the Earth with that accuracy. But then again, it does seem to imply that somebody was able to measure the Earth, that maybe there has been a tradition going back to who knows when, from the building of the pyramid, coming down through the age of the Greeks, right down to the building of the European Gothic cathedrals 800 years ago, a tradition of very sophisticated geodetic knowledge. Well, again, this opens up a huge can of worms about when people were supposed to, what they knew and when they were supposed to have learned. So there's another dimension to this as well, and this is, I'm only going to show you a few examples out of hundreds of possible examples I could be showing you. Ancient writings, Semitic writings, and I'm coming with two examples here. The Hebrew ancient writings, which would be Kabbalistic writings, the Hebrew Old Testament, the Torah, the Midrash, all of those. And then the Greek alphabet, the New Testament was written in Greek, all of the Pythagorean and Neo-Pythagorean literature written into Greek. Well, as it turns out, both of those languages, this was prior to the advent of the Hindu-Arabic numeral system. The Hindu-Arabic numeral system is when we came up with what we now have, is we have our alphabet and we have our set of numbers. And they're two different things, right? We use our alphabet for the spoken language and written language, and we use numbers for calculating and mathematics. But they're different. You know, we don't, but prior to the advent of the Hindu-Arabic numeral system, in the Semitic languages, the same symbols that were letters were also numbers. And the key was what you see right here, called a denary system. So Aleph was 1, Bet was 2, Gimel was 3, Dalet was 4, He was 5, Waw was 6, Zayin 7, and so on, down to Resh, Shin, and Tau, 200, 300, and 400. Yud, which was considered the seed of the Hebrew alphabet, had the value of 10. Okay, so units, tens, and hundreds. Then there was a symbolic component to each of the, for example, Aleph originally was the word for an ox. And Bet was originally the word for house. Gimel, originally the word for camel, and so on. Then we get to the Greek system, and it's also a denary system, units, tens, and hundreds. So alpha, beta, gamma, delta, epsilon, digamma, zeta, eta, theta, etc., 1 through 9. Then iota, kappa, lambda, mu, nu, xi, omicron, pi, kappa, 10 through 90, and so on. Rho through Sampi wasn't actually a written letter, it was just simply included to get the value of 900. Okay, so we have the same system, units, tens, and hundreds. So how was this employed? Well, here's an example. Here's aletheia, which was the Greek word for truth. And if you add up the eta, the alpha, the lambda, the eta, theta, epsilon, iota, and alpha, based on the values that I just showed you, the total value is 72. And that's one of our key sacred numbers. Because most of the numbers that I showed you here are multiples of 72, 36 or 72. Katabala, which means conception, the first moment of creation. Kappa, alpha, tau, alpha, beta, omicron, lambda, eta. Take the values again directly from the historically authenticated table that I showed you, and they add up to 432. So there you see these numbers showing up here. Yerushalayim, or Jerusalem. Iota, epsilon, rho, omicron, upsilon. This would be the Greek spelling in the New Testament. Sigma, alpha, lambda, eta, and mu. There's the values of the individual letters. Iota, which was 10, epsilon, 5, etc. And when you add those up, you get 864. Again, do we find that number on our list? Yes, we do. These numbers, again, are showing up with redundancy. The Temple of Immortality, Oneos Thanat. Let's see, I forgot how to pronounce that. Athanasius. Oneos Athanasius, that's it. The Temple of Immortality. So if we take that spelling, add it up, it also is 864. And I'll work on my pronunciations for next time. The Holy Ghost, Toagian Pneuma. Pneuma, like root of our words like pneumatic, means the Holy Ghost or the Holy Spirit. Add up those, the value of those, and you get 1080. The Fountain of Wisdom, Pegasophias, also adds to 1080. So these are just a few examples of, then I heard another great voice from heaven saying, "Come out, my people, out of her, lest you take part in her sins, lest you share in her plagues." A phrase from the book of Revelations and 1296, which is half of the great year cycle. So I mean, these examples could be multiplied by hundreds. Literally by hundreds. And this is actually one of the subdivisions of the study of Kabbalah, which is the gematria, the study of the numerical or mathematical basis of language. And what you discover when you go into the mathematical basis of language is the whole thing is constructed upon the same architecture of sacred numbers that we've been looking at here for the last hour. Probably you're all familiar with things like, "Here is wisdom, let him that hath understanding count the number of the beast, for it is the number of a man, 666. You ever heard that? Probably the most famous and controversial number out of the Bible, 666. Well, if you want to understand what that is actually referring to, you have to peel back the outer literal representation of these tales and look at the underlying mathematical architecture, because that's where it's concealed. And it actually turns out that the orbital velocity of the Earth around the Sun is 66,600 miles per hour, exactly. And that's one of the first astronomical connections, and then there's many, many more connections with that number that we find occurring in sacred geometry. So all of this, there's a lot of silliness and accretion stuff that's accreted to that, the belief in that number, by basically fundamentalists and superstitious people who don't look at the underlying science. But we will take a couple of minutes here and look at a few things. I lifted up, this is from the Old Testament, Zechariah, I lifted up mine eyes again and looked, and behold, a man with a measuring line in his hand. Then said I, Whither goest thou? And he said unto me, To measure Jerusalem, to see what is the breadth thereof and what is the length thereof. Old Testament prophet, Zechariah. So here was the beginning of his prophetic experience, his prophetic vision, as he sees this man who's got a measuring line in his hand. And he says he's going to go measure the holy city. And when he does, see, then what's the revelation that follows? The revelation is the sacred geometry that composes that is the basis of the architecture of the holy city. So the whole revelation is really, it's a geometric revelation. Again from the book of Revelations, and I looked, and lo, a lamb stood on the Mount of Zion, which to anybody who's versed knows that that's a reference to the sign of Aries, the lamb. And with him 144,000, which is this number right here, having his father's name written in their foreheads. What does that mean? Well, it means that somebody who studies sacred geometry, eventually, you've got these numbers as such an integral part of your consciousness in your forehead, in your frontal lobe, your waking consciousness, that these numbers literally become a part of the way you experience reality and experience the world, because the numbers are all around us in the world. It gives a shape to the world. It defines the periods of time that governs the cycles of our life. And I heard a voice from heaven as the voice of many waters and as the voice of a great thunder. And I heard the voice of harpers harping with their harps. And they sung, as it were, a new song before the throne and before the four beasts. What are the four beasts? The bull, the lion, the eagle, and the man. Divides the cosmic wheel into periods of 6,480 years, which I certainly should add, because that's an important number. So there's a veiled reference to that cycle of time, 6,480. And no man could learn that song but the 140 and 4,000 which were redeemed from the earth. Now, when you get into Kabbalistic studies, you can go to the English translations to kind of lead you into the outer portals. But if you want to get into the inner teaching, you've got to go beyond that. You've got to go back to the original languages. And I'm not going to get too much into that, but the word redeemed is actually a very interesting word. It's talking about the redeemed of the earth, 144,000. We discovered that the word was agorazo, from agora, and it means to go to market. So basically what it's saying is that those who achieve salvation at the day of judgment are those who go out and go shopping. What? Well, isn't that what George Bush told us to do after the, yeah, see? So George Bush, he had his thumb on the pulse of, but actually, see, why does it, what's the connection with going to market? Well, as a place, properly the town square, that should be the first clue, the square. See, there's your geometry. As a place of public resort, by implication, a market or thoroughfare. So the idea first is the idea of a square, because the marketplace would be built around a square, a literal square. So it became associated with the idea of people gathering within this square. See, it comes from, well, agorazo comes from, yeah, see here. So to go to market, by implication, to purchase, especially to redeem, And it comes from this root, agora, which is related to this, aguero, the idea of collecting one's faculties. This is the idea of collecting within the square again, right? Well, this, thinking now about metaphorically collecting one's faculties, but also to awaken or to rouse literally from sleep, from sitting or lying, from disease or death, or figuratively from obscurity or ruin. It means to awake, to lift up, to raise up, to rear up. So see, all of these ideas are what you're led to once you start going into the original Kabbalistic meanings of the language. So what starts out like go shopping, go to the market, means going to the town square. It means the gathering within this square. So here's the link with your geometry. But then one of the words that we look at when we study the Kabbalistic study of words is we look at the original roots, but then we look at how did they bifurcate and how did they lead, because you can follow the evolutionary paths of language to get back to what some of the original meanings actually were, to try to get to what the authors of these sacred writings were really trying to get to. Because you've got to remember that all of these sacred writings have gone through multiple layers of translation by people who may or may not have understood the original doctrines that were concealed in there symbolically and mathematically. Also from the book of the reference to the new song is very interesting, because and I would defer later to Jeremy on this, who's been studying the sacred geometry of music, but there is a Phrygian mode of representing the octave that goes from 432 cycles per second to 864 cycles per second. So the reference to singing a new song suggests to me that possibly we're talking about a change in frequency involving life here on earth, and that those who change their consciousness accordingly will be in harmony with the changing frequencies. And I believe that that is one of the core teachings of this, is that as Earth goes through its evolutionary journey through the galaxy, through varying geometric relationships with the astronomical universe, what is happening is that the frequencies impinging upon the Earth are constantly going through an evolution as well. And part of understanding the ancient secrets or methods of the master builders of old was utilizing the sacred geometry and the geodetic knowledge to create structures that resonated with the Earth because they were harmonically attuned to the Earth. I think that's part of what's going on, trying to understand the sacred science behind structures like the Parthenon and the Great Pyramid and many of the other temples is this science of harmony, of the science of resonance, and creating structures that vibrated according to certain frequencies, and those frequencies would be attuned to the slowly changing frequencies of the Earth itself as it goes on its cosmic journey through the universe. I saw a new heaven and a new earth, for the first heaven and the first earth were passed away, and I, John, saw the holy city, the new Jerusalem. Jerusalem is the 864, right? 864, that's the Jerusalem. Coming down from God out of heaven, prepared as a bride adorned for her husband. And there came unto me one of the 7 angels, saying, Come hither, I will show thee the bride, the Lamb's wife. And he carried me away in the spirit to a great and high mountain, and showed me that great city, the holy Jerusalem, descending out of heaven from God, having the glory of God. And her light was like unto a stone most precious. It had a wall great and high, and had 12 gates, and at the gates 12 angels, and names written thereon. Now, of course, those names are mathematical keys. On the east 3 gates, on the north 3 gates, on the south 3 gates, and on the west 3 gates. And the wall of the city had 12 foundations, and in them the names of the 12 apostles of the Lamb. And he that talked with me had a golden reed to measure the city. So here again, we have this idea of the measuring of the city, because the city is the repository of the cosmic doctrine. The gates thereof and the wall thereof. And the city lieth 4 square, and the length is as large as the breadth. And he measured the city with the reed 12,000 furlongs. The length and the height of it are equal. And he measured the wall thereof 144 cubits, according to the measure of a man, that is, of the angel. Now I find that verse to be particularly potent in its meaning, because first of all, we have to ask the question, what are we talking about what is the Bible talking about when it refers to angels? Well, you know, the counterpart to angels are found in all cultures. It's just in the Bible they're called angels, who are the messengers, right, from this other domain. But in other cultures, they were usually referred to as the gods. And basically, in the Christianization of the ancient pagan traditions, the gods were replaced by the angels, but their function within the cosmic hierarchy is identical. And so, the fact that the measure of a man, a human, is the same as the measure of the angel is very interesting, because it's saying that we're somehow linked to the gods through a common system of measure. But notice the numbers, 144 cubits. Of course, you got to ask, what is a cubit? And that leads us into some interesting digressions there. Also the 12,000 furlongs. Well, anybody know how much a furlong is? What is a furlong? Furlongs have almost fallen into disuse. It's a British or English unit of measurement, but it found its way into the King James Bible. It was basically the British counterpart of the Greek stade, which had various lengths, but basically the same length as the furlong. What was the furlong? Furlong, where is a furlong used today? Yeah, who goes to the track? Horse racing. A furlong is 660 feet, 1/8 part of a mile. Well, here's what's interesting about the furlong. If you multiply it by 12 to convert it to inches, you discover that the furlong is exactly 7,920 inches. Where did we see that number? This is now a test of your memory. The diameter of the earth. Remember I said the diameter of the Earth taken through the tropics, the sacred number that's representing the Earth? The furlong is to the inch as the Earth is to a mile. It's a proportion. This is a sacred proportion that was intentionally embodied into the units of measurement. So that we lay out a furlong, right, 660 feet, 1 inch, which is derived from our thumb, the width of our thumb, right there, you can check it out. Put your thumb on there and you'll discover it's an inch wide. That's the digit. So the thumb is to your foot in this cosmic relationship of 12 to 1. And when you pace, like this is how a pace was generally considered. You start from one point, put your heel against a point, and in every other step you count. 1, 2, 3. 1,000 of those, averaging 5.28 feet, gave us the mile. Right? 1,000 times 5.28 is 5,280. And that was the origin of the mile. The mile is literally a mill, 1,000 human paces. The pace, think about the pace, what that is. Our foot, our pace. Our pace, our foot is what anchors us to the earth. Our pace is what moves us about the face of the earth, right? The most fundamental relationship we have with the earth, our feet, right? That ratio of pace to foot, 5.28. Now, we have, the furlong is 12,000 of these things, right? 12,000, the holy city is 12,000 of these things, 660 feet. Multiply that out, you discover 7,920,000 feet. So how big is that? Well, divide that by the number of feet in a mile, 5,280, and what you discover is it's precisely 1,500 miles. So what would be 1,500 miles in diameter? Is there some object out there that could be 1,500 miles in diameter? It's certainly described as being something they see in the heavens, right? Well, I'll leave this one an open-ended question for right now, but here's something that's interesting. If we take this number and divide it into, compare it to the Earth, to get a sense of scale, Earth, 7,920, Holy City, 1,500. So we put 7,920 over 1,500, and if you quickly do that calculation in your head, you'll discover that 1,500 goes into 7,920, exactly 5.28 times the relationship of our foot to our pace. So here's a very strange correlation. The earth to the holy city is the same as the pace to the foot. What are they trying to say there? Well, one of the implications of this, it follows from this truth. The truth is that we humans are ultimately designed according to the cosmic measure. We were created in the image of God, right? And God is the ultimate cosmic measure. And we, being created in the image of God, embody the cosmic measures. So when Protagoras said man is the measure of all things, what he was implying is that we are the ultimate yardstick for the cosmos. In fact, when one looks at the scale of phenomena, from the human up to the largest macro scale that we know of, and from the human down to the smallest micro scale we know of, where are we within that hierarchy? Right smack in the middle. So there's as much above us as there is below us. There's as much greater than us as there is lesser than us. And I think that's one of the implications of this, is that when we begin looking at our sacred geometry, we realize it's the ultimate fusion of all of these phenomena on all scales, and the ultimate component, or the ultimate symbol of all that fusion is we ourselves. And then, of course, ultimately it's our consciousness, because, like it said, with his name written in our forehead, what that means is that when you study sacred geometry, you're literally building an edifice in your consciousness. You're building a form out of your own, the material of your own conscious mind that reflects this order of nature, of cosmic nature that's all about us. And that's the power, and why study of sacred geometry can ultimately be a key to accessing lots of other things like the Kabbalah and the alchemy and the Hermetic wisdom and the Gnostic traditions and the traditions of the Vedas and so forth. There it is, 12,000 furlongs. The city lieth four square. 48,000 furlongs on a perimeter. It's also described as cubical. 12,000 furlongs equals 7,920,000 feet, which equals 1,500 miles. The total perimeter, 31,680. That has a profound mystical significance, which we will save for another time. So there it is, a tabulation of some of the stuff we've covered. The diameter of the earth, 7920. 1 furlong, 7920 inches. The diameter of the New Jerusalem, 7,920,000 feet, which is 1,500 miles. 1 mile is 5,280 feet, or 1,000 paces of 5.28 feet. 1.5 miles is 7,920 feet. And here's the pace to the foot, equals the earth to the holy city, which equals 7,920 to 1,500, and there's that magic ratio of 5.28 that links the earth to this other cosmic entity, for now going unnamed, that relates to our own scale exactly as our pace does to our foot. And what you discover is that if you're taller or shorter, it doesn't matter, because it's a proportional relationship. If you're taller, your pace, my pace is in excess of 6 feet. So 5.28, you're going to have a somewhat shorter, but you're going to discover that the ratio is relatively constant. Because as you get taller, presumably your feet get bigger, with some exceptions. I know some little people with really big feet. And here is the Hebrew cubit, which is 18 inches. Remember, 144 cubits according to the measure of a man, that is of the angel. We have the Egyptian royal cubit of 1.727 feet. The wall of the city was 144 cubits. If we take the 144 cubits that are the Hebrew cubits, it's 216 feet, or 2,592 inches. Add 1 0 on the end of that, and we have the great year cycle, 25,920 years. If we express it instead in Egyptian cubits, which may have been the original intent, if not implying that either cubit was legitimate, 144 Egyptian royal cubits of 144 times 1.727, 248.814. Move the decimal over 2 points, you got 24,881.4. Call that miles, and there's the circumference of the earth, 24,881 miles. So there's all kinds of information embedded in here, but you've got to have the key to begin to unlock it. Okay, and then also notice that the moon, 2,160 miles, or 17,280 furlongs, we set the diameter of the moon to the diameter of the holy city, there's our 1.44 ratio. So what we have here is this redundancy over and over again. We have these same numbers recurring over and over again in the measure of time and space, both in absolute dimensions but also in the proportional relationships that result from comparing these various entities of time and space. As we've learned now, the diameter of the moon is 2160 miles, the diameter of the sun is 864,000. As it turns out, if you take the diameter of the sun and multiply it by this number right here, it gives us the distance between the earth and the sun. And if we take the diameter of the moon, which is 2160, multiply it by the same factor of 108, we discover that we now have the Earth-Moon distance. So it's this 108 factor, this 108 spacing, this proportional relationship. We could express it this way. Solar distance to solar diameter equals lunar distance to lunar diameter, and the value of that proportion is the sacred number 108. As we see embodied right here in Baheng of Cambodia in the 12th century with its 108 towers. And there are many examples of how these numbers were incorporated into the fabric of sacred architecture. That there has been some kind of a universal system at use in the ancient world. And these various cultural groups, whether it was the Egyptians or Sumerians or Mayans or the Hopewellians or the megalithic builders, had access to some universal system from some source that was outside their own cultural context. And I suggest that the source of that goes back into deep time, that takes us back beyond the threshold of known history into the realm of mythical history, which means we're going back like into the Ice Age, back into the Pleistocene, to use the geologist term, back into the deep recesses of the human tenure on planet Earth, whose only memory has come down to us not in the form of recorded history, but in the form of myth and epic story and legend and so forth. Because as it turns out, if we, and this is again is a good topic for a sacred geometry class, when we analyze Plato's description of Atlantis, Plato basically gave the date of the sinking of Atlantis as 9,000 years prior to Solon, the Egyptian, the Athenian poet and statesman. Solon did a 10-year exile in Egypt, and it was Solon that brought back the tale of Atlantis and presented it to the Greeks. And Solon basically made that journey around 600 BC. So if you add the 9,000 years to the 600 BC, we come up with a date of about 11,600 years ago for Plato's date for the demise of Atlantis. Well, it's very interesting that the date 11,600 years has been independently discovered by geologists looking at the tempo of various catastrophes that have occurred on Earth. And to those catastrophes is where I'm now going to turn. Catastrophes in the time of man, the tempo of global change. What I've done here is I've put a time bar that goes from the present, right here. This is us now. This is today. Right here is May 3rd at 4 o'clock. Is it 4 o'clock? That's right here. And this is 150,000 years ago. And the reason I used 150,000 years is that some of the earliest skeletal remains ever discovered of modern humans date back to 150 to even to 180,000 years. Skeletons that appear to be indistinguishable from a modern skeleton, which suggests that modern humans with presumably equivalent intelligence to our own were present on the planet at least this far back. So here we've got a 150,000 year time span. You'll notice this little red bar at the end. That red bar represents the span of recorded history, which is basically the advent of Sumerian cuneiform writing. So if it turns out that there were modern humans living through this whole span of time, why is there no history? Well, now you got to do is turn to these various.
Yo, thanks for being here, Stash.
Put on here.
Toad, Christian, everybody.
And
Angel,
I used a certain criteria for
Ziesel.
these events. Here's the criteria I used. I began
Thank you so much for being here.
The record of geological change, climate change, environmental change, and I focused on
Thank you so much.
events that could be considered catastrophic. And catastrophic to the extent that were an event of an equivalent magnitude to occur now, it would basically end civilization as we know it.
For sure.
That's the
Thanks,
criteria.
dude.
What would be
Thank you so
what would be
much.
the magnitude of an event that it would take?
Now you can hang out in Dogger's
modern
stream.
industrial
Unlike last time you had to
civilization?
leave, now you can stay, hopefully.
That's
Hopefully.
the criteria that I used. Then I began to search through the record of all of the events that would be of that magnitude or greater. And the events that I found so far have been entered onto this